So hello everyone, today we are going to cover session number 21 in which we are going to see further features or further remaining relations in assemblies. So to start with, I have made two simple parts. We are going to refer that parts so as to see other remaining mates. So for that, I am going to say insert components. So I have this plate here. I am going to browse that plate here. And this time we are going to keep this part grounded only. We can see here after clicking any part, the related mates or relationships are shown in the model tree at the lower side. So here we can see grounded mate is being shown on the plate. Earlier we have related that relationships and matched the planes with the assembly planes. But this time we are going to keep it grounded only. So this is the ground mate. Next we are going to take the copy of this plate only again. We are going to place this plate on this upper face. So I'll say assembly, this bottom face on the other face. I'll flip the part here, say right click and finish. Next, if I want to drag this part, I'll drag it here. I want to rotate it here. So I'll keep it in this way, freely move it. I'll keep it in this position here. Next, we are going to go for mate. So this drag component helps us to move the part as we require. Say right click and finish this command, or else say escape. Next we are going to see connect mate. It is used to connect two vertex points of any objects, center points, vertex points, any 3D points or 3D edge points. So I'll select this command here, connect. I'll select this corner point of the upper plate and then select the edge here. But before selecting the edge, I'll apply the distance here. I'll say 20 mm and then going to select this edge. So this distance in y direction is 20 mm now between this point and this edge. Suppose if you want to edit the distance between this corner point and edge, you just need to select the part related to the mate. Select the related mate and here you can change the distance also. So I'll keep this distance as 60 mm, say escape and finish. Next, I'm going to place this point reference with this edge also now with distance only. So again, connect command, select the vertex point, select the required edge with reference to which I want to apply the distance. So I'll select this edge here and say escape. So we have not put the distance value at that time. So if you want to edit and put the distance value again, just click on the part and you can again apply the distance. So I'll say here 20 mm. So now we can see this part here, it is having 60 mm distance from this vertex point and in X direction, that is horizontal, it is 20 mm. Now if we observe it from upper side, we can see this face is looking parallel to this face, but it is not in the actual case. For justifying that, I'm going to go for the angle mate here. Select the angle mate, select the reference faces in between which we want to provide the angle. Then put up the value here. I'll say the value as 5 degrees here and then select the perpendicular reference face. This third face should be perpendicular to the above two faces. So I'll select this face, the upper face of this horizontal plate. And we can see from the top side orientation, this face is now inclined with the 5 degrees angle in between these two edges. This edge and this edge is having 5 degrees angle now. In this way, you can use point command and apply the angles between two faces. So we have covered two mates here, that is angle mate and point to point contact mate, that is connect mate. If you want to change the angle, then select the plate, select the related mate, and here we can update the angle. I'll say 10 degrees now. So here you can see this point is not moved. It is because we have applied point and edge distance. This vertex point is not moved. This is because we have applied distance between this edge and this vertex point in y direction as well as horizontally also we have applied the distance. That's why this point will not move and this fixed point will act as an anchor point so as to take the angle from this face. That's why this plate is looking inclined, but this point is at the same place with the reference of which we have provided the distances here, that is 20 and 60 mm. So now we are in assembly mode and we want that two parts should be made in a relation that they move in angles. But the angle should have one range, that is maximum and minimum range. So to apply that range, I have called one part here. You can see here this part. And I'll call the same part again as a copy. So I'll drag this part again. Next, we are going to make it in a position so as to make them in an angular way. For that purpose, I'm going to select parallel relation first. We'll select this upper edge of the plate, second plate, and the upper edge of the first plate. Both the edges of the plates are coincided as well as parallel, but the offset type condition is kept fixed. OK and escape. Now we'll see whether it is draggable or not. I'll select this drag component, click on the part, and you can drag with reference to this axis. So you can see here, it can be dragged here. Next, I'm going to say coincide here. So for coincide, I'm going to click mate option, select both the faces here. I'll say flip part, and now both the parts are being coincided. Say close again. Next, we can rotate this part by drag component. So I'll select the drag component again. Now I'll say to rotate this part, click on the part. I'll say freely move. It is rotatable, means there is no angle limit. That's why we can rotate it completely here. So to apply the angle limit, I'm going to go for this angle option. And in angle relation, I'm going to select both the faces in which angle is to be applied. Put up the angle value as 60. I'll select the angle format. This angle format is nothing but quadrant system. In which quadrant we want the 60 degrees angle to be applied. So I'll select the fourth quadrant here, fourth angle, and then select the perpendicular face. Means first we have to select these two faces, then select the angle format, then go for the angle, and lastly select this perpendicular face. The order should be followed in such a way only. Now this angle is also been applied. I'll click on this plate and you can see here 60 degrees angle is been applied. Suppose if I change the quadrant and say first angle, and if I change the value to 60 again, now you can see this quadrant is coming in first only. You just need to select and see it is taking first quadrant. Again we'll go for the fourth quadrant so as to bring this part at the upper side. Select the part, go for the angle editing. These angle formats will change the quadrant systems here to position the part. Suppose if I say sixth angle and say 60 degrees here, you can see it is coming at this position. So these are nothing but quadrant changing only. I'll select it again and say fourth as earlier and say 60 degrees angle again. So now we want to apply the range between these two angles. For that I'm going to select the plate, select the mate, and instead of keeping it fixed I'm going to say range here. So now in range the minimum angle is coming at 0 degrees and maximum is coming at 60 degrees. So we'll just keep it here, and we can see here now by dragging this component you just need to say free move, and now it is moving only till 60 degrees here. It will not go further that angle, neither in downside nor in upside. So here the range is been applied in angles for the two parts. You can see here in this way you can apply the range angles also here by using angle mate. Next important thing we are going to see here is we can apply this range in distances also. Again we'll take the same part as a copy. Here I'll say assembly to this face and this face. Next we are going to coincide these faces also here and these faces also. After applying this all the mates, you can see both the plates are coincided to each other. So for applying the range now, I'll select this part. You just need to go on the first option, that is this side faces were coincided earlier. I'll select that one. The coincide faces you can see here in orange color. Next we are going to apply range here also. I'll select on the range and I'll say the maximum value to be taken as 60 mm. Now if I drag this component here, just click on drag, select the required component and drag it here. You can see this range has been applied. If I say move also, in next direction it will move. 60 mm range was applied. Instead of range, we can also do one more thing. If you just want to move it without having any range values, then select this part, select the required relation, and instead of range, we can say it float. So after applying the float command, we just need to drag it here. It will not have any range, but we can drag it anywhere without having any range value. So it may intersect also, it may go far away from the part also. This was float option, say close. So in this way you can apply the range to angles, range between distances, as well as you can make the condition as float between two objects, so we can drag them for temporary position to apart from each other. Next we are going to go here for tangent mate. For that I am going to call this part, that is wooden pin here. Now this pin should be kept on this flat face. The surface of this pin is circular and this face is flat. So to position it properly, I am going to apply here the tangent mate. Select the tangent mate, select the face, select the other flat face, and you can see here this part has been kept on this face here. That is tangent. If I want to flip the condition of the part, it will go on the lower side. You can see here, but the orientation is coming at the lower side. If I flip it again, it will come at the upper side. So in this two alternate position, I can flip this part here. Next, we want this part to be placed at the center of the plate. So for that, I'm going to go here and say this option, that is center plane mate. Select this mate, and now it will show the selection mode in two formats, that is single and double. We'll see one by one each. So first I'll select this single one. So in single selection, I will select this circular face here, and the other two faces I'll select this one. So the single selection is only for selecting the first face, whether single or double. Next faces should be selected, two only. This part is been placed here now. We'll repeat it again. I'll undo this part. Again go for this mate, that is center plane. Select the condition here as single. So the single face, I'll select this circular face. I want this part to be placed between these two faces. That's why selecting these two faces. So here this center plane mate has been applied. Next I want this orientation of the pin again here at the center only. Again for that I am going to go for center plane, but this time I will change the condition and say double. So in double condition, you can see here I will select these two faces now. So the component to be moved at the center can have two face selection here with reference to the other two faces of the plate. Earlier we were taking only one face for the part which can be moved. This time we have taken two faces. So in this way you can place this part at the center by using center plane option. So we have covered here center plane mate, tangent mate, angle mate with ranges, and distance mate also with ranges and floating conditions. Next we are going to see here is clone component and duplicate component. So to start with, I have called this part here, this base plate. I'll call this part again as a copy here. So take this plate here. We'll apply the distance between two plates. For that, say assemble. Select both the faces here. Both of them are coincided now. I'll say right click and escape. Next again I'll select the plate related mate, and we are going to apply the distance. So the distance type I'm going to keep here is range. So it will ask me minimum value and maximum value. So I'll say the maximum value here as 40 mm and minimum as 0. So right click and OK, finish. Next, if I go for drag component, say move, select the face. You can see it is moving till 40 mm now, maximum, and minimum it will go 0. Next I'll say assemble and again match these faces here. Match this face also, side faces. Say right click and escape. You can see here, if you drag this component, it is taking maximum 40 and minimum 0. Next we are going to call the part, that is bolt. Say right click escape, and we are going to go for mating this part, say assembly. I'll select the axial align. Next, say coincide again, face to face. Select this face and the other face. We can see here this part is positioned, but still the rotation is on. That's why it is not completely defined. So I'll put off the rotation here. Say click on the made related made and say lock rotation. So after locking this rotation, we can see this part is completely been made here. Next we are going to call the nut here. Last part. Say assemble. Say axis with the bolt axis. Again assemble only. Say face to face made. We'll lock the rotation here also. Select the component and the required related made will appear here. Select it and say lock rotation. If I want this bolt and nut to be patterned here, there are multiple ways. First one is selecting pattern command only. Selecting the parts to be patterned here, say OK. Then selecting the base part which contains the pattern. Then selecting the feature patterns and then going for the base hole pattern. All the bolts and nuts are being patterned together only. You can see here. We'll go for the next option, that is clone components. We can use this option also, clone component. For that we need to delete this pattern here. So I'll delete this pattern. Select the clone component option. It will ask you to select the components to be cloned. Say OK. After selecting the components, select the base hole. Say OK. And you just need to click on the other holes. Any one hole you can click here and say OK again. Say finish. In this way you can pattern these parts in clone components also. You can see here it will show an assembly group. If you expand this assembly group, these parts will be shown in this way. I'll again delete this option also. Next we are going to go for duplicate component. So we cannot duplicate the bolt here. As bolts we required here is total number of bolts we are requiring here are 4. But the parts on which the bolt is mounted are only 2. So this combination will not work. For duplicate components, it is necessary that part to be patterned should have equal number of parts on which the part is going to be patterned. First we'll go for the clone component for the bolt. Say OK. Select the reference hole and select any one hole here. Say OK. Select the hole here. Say OK again. So after cloning the bolts, now we can go for duplicate command. It is because the total number of nuts we require are 4 only. And we already have 4 number of bolts. So numbers are matching now. That is the main requirement for duplicate component. Select the component to be duplicated. I'll select this nut. Say OK. And you need to select the bolts here. And you can see the nuts are also being duplicated on the bolt. At the bottom side you can see all the 4 nuts are being duplicated. Say OK and finish. So in this way you can use duplicate component and clone component. For cloning components, the base part and the part to be patterned are not required in equal numbers. But for duplicating components, the base part and the part to be patterned are required in the equal numbers. That is the main difference between them. After that, we are going to go for the assembly now. We are going to assemble the double bearing assembly here. I'll say new assembly. We'll browse the parts again. Double bearing have made the parts earlier only. So I'll browse the parts. So here we have the double bearing parts. I'll first call the base part here. We'll keep this base part grounded only. Next part we are going to call here is this bushing. We'll make axial align here. We'll flip the part orientation. Say coincide now. So for coinciding I'm going to use this mate. Select the face, the other face to be coincided. Say right click and finish. We can go for the clone component or else we can do mirror also here. So for mirroring we required the plane, but we are not having any plane in the center. You can see this base reference plane are not lying at the center. So for that we need to take one plane also. Here we can add the assembly features and go for the planes option. So we'll count the distance first. Say inspect, measure, select the type of selection as faces. So the distance here is 90 mm. So for centering the plane we need to apply the distance of 45. Again go for features. Go for the planes parallel, select the face required for the reference and go for the distance as 45. Now you have one plane also here in assembly. We can use this or utilize this plane for the mirror again. So go on the home option. Here we can say mirror component. So for mirroring the component you need to select the component. Say OK, then select the required plane, reference plane and say OK. This chart will show the components to be mirrored. Either you are having 1, 2, 3, whatever the number and names, and the action with the adjustment will be shown in this chart. Say OK, say finish. Again I'll undo and make it mirror again. So we have taken the plane from assembly features. There was the option of plane. After taking the plane, we have gone for the mirror option, selected the part, said OK, then selected the required reference plane and said OK again. Here we have the part that is mirrored. We'll go for the next part, that will be this cap. We'll make this cap a little bit movable. So I'll say move component, select the part. So we need to select a face which will be perpendicular to the wheel so as to move this or rotate this part. So I'll rotate this in this way, as the orientation of plate will be in that way only. Again click on the part, select this point, place this point on the perpendicular face with reference to which we want to rotate the part, then just drag this component here. Say right click and finish. So after rotating the part, I'll go for the mate. I select assembly and select this axis with reference to this axis. Same for the other part. Next, we are going to say coincide with these two faces. We are just clicking on the assembly tab and the required mates are been applied. That is because assembly tab is nothing but flash fit only, and flash fit applies the most appropriate relationship from the mates. We don't need to select the required mate here. We just need to click on the flash fit and the required mate will automatically get applied. So here the cap is also been fitted here. Next, we are going to call the bolt. Say right click, and now for inserting the bolt we have the command that is insert. This command is very useful as we don't require to give 2 or 3 relations. In one relation only this part will be mated there. Select the insert tab, select the axis to axis option, then go for the face to face option to be coincided. This part is been placed. We don't even need to lock the rotation will be automatically locked. You can see here this rotation is by default locked only by applying the insert mate. So in only one mate or one selection, this complete part is fully positioned here. Next, we are going to go for the option that is clone component. We would have applied pattern also, but we can see here these holes are not at the equal line references. They are not aligned equally. That's why we are not going for the pattern command. We are using clone component. So in clone component, select the component, say OK, select the reference hole and the other holes also. After saying OK, select the other holes. I select any one click and complete bolts are being placed on the position there. Say finish, and this assembly has been completed now. This was double bearing assembly. Now if we need to explode the assembly, we just go to tools, say era, select the option era. Era means explode, render and animate. So I'll select this option here. There are 2 options been given, that is auto explode first, say top level assembly, say OK and explode. So the part has been exploded here, but the distances are taken by system itself. They are not evenly placed. So if you want to continue with this explode, you can continue, or else we can manually explode it. So to undo it, again say unexplode, say yes. And now for manual exploding, I'll say explode command. Select the parts to be exploded, just follow the prompt bar here. Select the parts to be exploded, say accept, select the base reference part. After that, select the face by which reference we want to apply the distance. Select the direction of the distance, say OK. And you need to apply the distance here. I'll say 70 mm only. Say explode. Next, say finish and cancel. The other part we are going to explode here is this part. Select this part, say explode again. Say accept. So the base reference part, then the face reference for the distance and direction. Apply the distance here. I'll say it 45. I'll say 35 only. Say finish. Say accept and cancel. Next parts, again these 2 parts. Control press and select both the parts. Say explode. Say accept. Select the base reference part. Select the face from which you want to apply the distance and direction. Say OK. We need to apply the direction and say 35 as a distance. We can go for the more distance value also. So I'll say 80 mm here. Say finish and cancel. So in this way you can apply the distances here and change the positions of the explode. So this was explode command. So these were the points which we were going to learn in this lecture. We'll continue with the assemblies in further lectures. Till then, thank you.